Okay, welcome everyone. This session is dedicated to explore the future of how we create and evaluate scientific knowledge. Today, we are pleased to present and to have the opportunity to hear all about this amazing project that is going on in this moment by Erik Schneider, founder of Referee Project. There is an initiative that is also innovative, but in the same way a little provocative, I will say, that aim to completely rethink about how we approach peer review in academia. In this way, I will give the floor to Erik. And tell us, Erik, who is Erik and actually what took Erik to start with this initiative?
Well, thank you, Sebastian, and thank you to everyone who's joined. My name is Erik Schneider. I'm an American, but I live in the Netherlands, and I've lived here for 11 years. And I have quite an eclectic background. So initially, I was in arts and antiques. Then I was going to be an academic. I was in a PhD program, so I got a close look at academics. I left that and practiced finance. And then I moved to the Netherlands in 2013 to study cybersecurity. I did that for a number of years. And then I worked for Insider Risk, which is kind of a related field, before starting Referee. And the genesis of Referee really started with a podcast that I listened to with Adam Mastriani. Adam Mastriani is a psychologist. He is a Rhodes Scholar, and he was very frustrated with peer review. In fact, he argued that peer review is, if you look at the history, even though you can trace it back hundreds of years, in modern academia, it really didn't become a big thing until the last 50 years or so. And he's right in that regard. Academics always would share their papers with some peers that they trusted for some feedback. But then it really became sort of industrialized in the last 50 years with academic journals. And he thought that with the rise of preprint repositories, where you can just submit your paper publicly, other people can look at it, they can provide feedback, they can judge whether it's important or not. He thought that was a better method. But I think he's wrong on a couple of aspects. For one thing, academic journals seem like a racket. They make tremendous money. They make billions. I think it's about a $30 billion a year industry with 40% profit margins. And if you're an academic, you have to pay to get your paper published. If your paper is selected, you pay to get them published. And sometimes it depends on the journal. That could be over 1,000 euros or dollars. And then you have to pay to read it. So you have to pay to publish it. And then you're asked to do peer review on other people's papers. And doing rigorous peer review is hard work, and they get paid nothing for it. So there are many people who are frustrated with the system. So I can understand the motivation to create a better system. But the journals do something that is important, which is to decide which papers are worth publishing, which ones are novel enough. And for that, you need real expertise, because the amount of papers that are published in these preprint repositories number, I think, hundreds of thousands every year. Who is going to go through on their own time and evaluate these papers? It's a very tough ask. And as we get into Referee, I think, relying on academics to do this is actually not going to be the solution. So one is academic journals actually do provide a valuable service. The second thing is that peer review is absolutely needed, because you need some quality check on the scholarly record. And right now, that is done in a very incomplete way. So he is correct that academic peer review is largely broken. It does not mean that the concept of peer review is actually flawed. I think the way it's implemented is flawed. And basically, so I don't want to get rid of the review of academic research. I do want to take the peer out of peer review, in the sense that relying on academics alone to do this kind of evaluation. And that comes from my background in cybersecurity. So in cybersecurity, there are two models to evaluate the security of a piece of software. One is to pay what are called penetration testers, which are basically ethical hackers, to come in. You pay them by the hour. and they try to find as many flaws as they can in the software. Now, they may earn their keep. They may present some really valuable flaws, and you'd be happy to pay them, but you just have no idea whether they're going to deliver above what you pay them. The second model, which has come into place over the last, I would say, decade or so, is bug bounty programs. And for bug bounty programs, you place a paid bounty for a very specific flaw, and anyone in the world can claim that. So, for example, on your iPhone, Apple has put out $1 million bounties for certain types of flaws. And to their credit, I don't think anyone has claimed that $1 million bounty, even though it's been around for almost a decade, maybe more. I don't know the specifics of it, but that's how strong their security is. But in this case, it's really a market value, and people, instead of getting a lot of vulnerabilities that you don't care about, you can say, hey, listen, for this really important one, I'm willing to pay anyone. I don't care what your background is. I don't care if you have a degree in computer science or whatever. If you can find it, you get the bounty. And I think that's what needs to happen with academia. But there are a couple of things that need to be in place in order to use the bug bounty system. So in cybersecurity, they have what's called the common weakness enumeration, which are about 900 plus ways that software can be flawed, but they're very abstract. And then they have what's called the common vulnerability enumeration, which says, okay, this specific flaw in this specific system, like a Windows or an iOS system, it's kind of like the realization, the tangible part. Anyway, I've looked in academia, and there is no taxonomy that's ever been created about all the way that research has been flawed, that can be flawed. So I created one, and it's right now about 250 plus, and I don't think it's complete, but this is a living project, and it'll grow and become improved. But you start with that, and then once you have these specific flaws, then you can start placing bounties on them. But ultimately, and I know this took a long time to get to it, but ultimately what the goal of the project is that for every paper, we want to put a reliability score on that. So that's just a number from 0 to 100, whether you can rely on that paper, whether that work is reliable. Now it's related to reproducibility, but really it's looking at the methods and the analysis and and this is the logic of the paper. It does not really care about whether it's important or new. It doesn't really that much care about ethics either. So if you plagiarize your literature review, well, you're lazy, and I do think that it's an ethical violation. But still, and if the rest of the paper was, very sound and correct, well, you could still rely on that paper. Maybe the literature review, like I said, maybe it was copy and pasted. But if the research itself was reliable, then you can do that. If you plagiarize your results table, well, that's a different question. So, but yeah, ultimately, you get a number from 1 to 100. I should say up front that we know that number is going to be wrong, just like all models. All models are wrong, but some are useful. And this number is going to be useful.
And a question, Eric. But till the moment, did you identify some project, somebody that is trying to solve the same problem?
Yeah, so there are many projects.
Actually, why so relevant now, this problem? This problem is something that anybody could till now to
so there's a lot of there's a lot of retracted papers, and that has been increasing recently. Retraction Watch is one nonprofit organization that keeps track of all the retracted papers, and that has grown exponentially over the last few years. And I think the total number is 58,000 papers that have been retracted. There have been some other estimates. Just in biomedical research alone, one article in The Lancet, which is a very prestigious journal, medical journal in the UK, they estimated that 85% of biomedical research is pretty much wasted. Either it's duplicating false findings, but it's not having impact. And like some of that is explainable. You have to experiment and try, and sometimes the results are not there. But I think the number is about $200 billion in biomedical research. I think that number is correct. So if 85% of that, that's quite large. We're talking huge numbers. And I think, to be honest, even though peer review started off between academics, there's so much money that is put into academic research around the world. We're talking hundreds of billions. I was trying to look up what the actual number is totally, but this is taxpayer money, and there needs to be accountability for how that money is spent. And to be honest, that's actually how peer review started. It started in when it became industrialized. In the US, the funding bodies like the National Science Foundation was spending billions of dollars, and the politicians said, well, can you give an accounting whether this research is actually useful? And that's when they really started hiring or enlisting peer reviewers to make sure that the research had integrity. But huge amount of waste. There's also the rise of paper mills. So paper mills will either create papers for a amount of money, but they will also sell authorship on papers. So in academia, the number of citations, the number of published articles is the coin of the realm. That's what you get measured on. That's how you get promoted. And it's very hard to get published. So they have these paper brokers that will essentially sell you a spot on a paper that's already been accepted for publishing, and you can add your name as a co-author for a certain price. And I think the final thing why this is a big problem is that AI is going to vastly increase the number of papers. There are also very suspicious statistics.
Mm-hmm.
There are some people who publish, if you believe them, they publish a paper every 5 days. So they're publishing basically 50 papers a year. That's really hard to
produce also, because at the end, in the way that at least I see it in my ignorance about this process, I will say that it's a kind of production process of knowledge, and also how you have the production line of knowledge, and to make it so fast, so something need to go know that good quality somehow.
Well, and that's the thing. Like when a paper gets I would say one thing that, whether you can trust something, the current method is we basically have two levels of trust. One, if it's published in a peer-reviewed journal, then you should trust it. If it's not been peer-reviewed, then generally you should not trust it. And if it's been retracted, you should not trust it. That's the current thinking. But this just kind of two levels, like complete trust or zero trust, well, that's a big problem. And that's why I want a number between 1 and 100, not just yes, trust, no, don't trust, because it takes a lot to get a paper retracted. Let's say you find a paper with a lot of flaws, you have to write the
I'm sorry, Erik, what do you mean when that takes a lot of time to make a paper retracted? What do you mean?
Yeah, so there are these researchers who look at papers and they find flaws. But in order to get retracted, you have to write the editor of the journal, usually multiple times. You have to present your evidence. The journal, if the journal thinks it's serious, they have to make a very important decision, because if you retract someone's paper, that stigma will live with that researcher really for the rest of their career. And so they make a big decision. So the long story short, the amount of evidence has to be almost overwhelming in order to be retracted. In most cases. In other cases, papers get retracted because of some political issue that the journal is getting a lot of heat because they published something that may be sound, but it doesn't fit a current narrative, and it gets retracted for that reason. But my point is that, and if you listen to what these fraud researchers say, they find a lot of papers where, they see a number that's there are things called impossible numbers where, just to take an example, if you rolled a single die, a 6-sided die 20 times, and you say that the mean is 3.83, well, that number is actually impossible, because you're dividing by, if you rolled it 20 times, you're dividing by 2. The last number either has to be a 5 or it has to be a 0. So you can be 3.85 or 3.80. The 3.83 is impossible. So these researchers find these impossible numbers, And they don't know whether the researcher, well, maybe it was a typo, maybe the researcher is just sloppy, but when you get 4 or 5 of them, you really start to have questions. Now, let's say that that was the only problem with the paper. You haven't really proven fraud, but you can't go to the journal and say, retract this paper because these numbers seem impossible. So there's got to be this huge middle ground where papers are very questionable. But right now, you don't know which papers there are because they probably still remain published. It's only the most egregious types of fraud that get retracted. And like I said, other researchers are trying to build on flawed papers innocently because they just don't know that they're flawed. They assume that they've been peer reviewed. They're not going to go check it again. Maybe they've looked at it and had some questions, but for the most part, they're going to say, well, it's been peer reviewed, so I can trust it. And they build on this research. And again, taxpayer money is spent on a tremendous amount of research that is in the beginning flawed.
And actually, now that you say this one with the taxpayer money, like the citizens that also somehow through the taxes invest in this, I would say, I don't know, quality insurance of the knowledge that through the government create. Also through the system of referee project would be also something for them that they can have like a more accessibility, or for them could be more easy to see how also this type of resource is using it somehow, or this part is really complicated.
So initially, referee is going to focus on finished research, but there's a lot of work on like before research started. So the funding, which is where academic peer review started, and say, hey, you submit a grant proposal, is this worth investing in? So in many respects, government agencies should be interested in this project because, again, once we can identify flawed research, and I should also mention that, referee is initially focused on cleaning up the past because I think there's a lot of, or we think there's a lot of errors in the past that have yet to be identified. There's no incentive to look for it, but referee will. But you need that clarity on past research, on the reliability of past research in order to fund new research productively. And most of the other peer review projects are just interested in how we do peer review going forward. But you have to clean up the past because that's where all the problems are. And I was going to say another thing. So one thing is that having cleaning up the past will help the governments make much better informed decisions. The other thing about peer review currently is that you submit a manuscript, it's sent out usually to at least 2 peer reviewers. They find it very difficult. Even the most prestigious journals cannot find peers to review the paper because reviewing papers to do it correctly is really hard work. But even if you get comments back, and so someone will make comments about your paper, a lot of academics don't want to fix their paper, and a lot of academics will just submit it to another journal rather than fix it, and oftentimes it gets fixed. But they're not made public. So when a journal article is published, you don't get to see what the peer reviewers, if they were honest and thorough, what they thought about the paper. So you don't know what questions were raised. And with referee, not only will you get that reliability score number, but you will also get all the flaws that were identified in that piece of paper. So why is that important? Well, you can make a judgment on whether you agree with the score. Maybe you don't care about these flaws. But the other thing is that research organizations that house and that receive government funds, there's no way for them to know where their researchers are weak. So to take one example, if all their researchers are publishing or attempting to publish underpowered statistical tests, and they clearly don't have a knowledge of statistical power, they need a refresher. So there's no way to do that right now. But with referee, you can take the results because they're very specific about what flaws were identified. This goes back to the researcher, but also to the research organization, and they can really help these researchers become better researchers because they know where they are weak.
And in this regarding, Erik, but what happened, for example, if in the referee system, if I understood correctly, for example, that they are also making the scoring in the way that they can have a better output with the which papers also have a better score. But what happens, for example, if a paper that is good through referee system get a bad score?
So a paper that is not flawed but comes out through a bad
in the
score.
assumption, yes, in the assumption, for example, that is a really good quality paper, but for some reason in this interaction with the system, the score is down.
Yeah. So a couple things on that. One is that we should be realistic about the expectations that, especially in the beginning, that there are going to be wrong answers given, and there'll be mistakes. So the way I've designed the platform is that the taxonomy and basically the weight. So you have a taxonomy of every flaw, and it's just does this flaw exist, like 1 or 0? I could make it like decimal, but it's just 1 or 0. And then you have a weight, and the weight is how severe that that flaw is. Now I'll start with my own weighting. And people could disagree with it. They can say, well, I think you overweight this and you underweight this flaw. And I really encourage that. I hope people come up with different scores, and so you can get a nuanced view. So again, one thing may be the score gets low because some flaws that were identified were heavily weighted. And maybe someone says, well, I just disagree. And if you use a different weighting, it looks a lot better. So that's one thing. The second thing is that score is only calculated at basically runtime. So when a user wants to look at that score, because it's just this, not to get too technical, but it's the sum product of 2 vectors. And that can be done in a fraction of a second. So it will, anytime anyone going to the system to check the reliability of the score, they will always get the latest score. Now, if someone wants to challenge it and say, your system has identified this as a flaw, and I disagree, well, they have a process to appeal. And, in the beginning, I'm really hoping that the way this, not that I intentionally want to create a bad product, but there is a saying that says, if you want an answer from the internet, you don't ask it a question, you give the wrong answer. So I'm going to give the wrong answer, not intentionally. I'm going to try to do my best, but undoubtedly the wrong answer will be given, and they'll say, you're wrong. This is not actually not a flaw. And then I say, okay, well, come help me make the system better. And that's what I want. I really want people, because I don't have all the knowledge. And one of my claims, the reason why the current system fails, the reason why every single project that I've seen that is trying to fix peer review is going to fail, is because they make the same 3 flawed assumptions. The first is that academics want to do this, and that they have time to do it. The second, and there's no evidence of this, like I said, even the most prestigious journals cannot find peers to take the time to do peer review. The second one is that academics have all the knowledge expert knowledge in all the ways that papers can be flawed. And this is why even when you have 2 earnest peer reviewers reviewing a paper and it gets published, that another person finds a flaw, because usually, like I said, I've identified 250 ways research can be flawed. And it's very unlikely that one person is going to be an expert in all those 250 ways, but B, can be looking for all those ways in the paper. And the third is that only academics can do this. So what you find in cybersecurity is that when people participate in bug bounty programs, they are not expert in the 950 ways that software can be flawed. They are an expert in one of them, and they know how to pick out that flaw like no one else. And that's what you want. So you don't want to review the entire paper by one person. You want one person going into many papers and looking for one flaw. And that's a model that works in cybersecurity. And right now, no one is doing this in academia, but it's, I think, clearly the superior method, because you want specialists in there who really know what they're doing.
Exactly. And now that if you can go a little more deep about the bounties system that you wanted to implement also in referee, for those people that maybe are not so related about how this one works, how or why somebody will start to, what will be the incentive to somebody to start to try to find these bounties?
Well, for one thing, there's money at the end of it, and potentially a lot of money at the end of it. Again, I said that academic publishing is about a $30 billion a year business. All the academic journals, but not only the academic journals, but academic conferences. So academic conferences, they often get 30,000 papers submitted to, asking to be accepted by the conference. It's just too much. And again, they cannot find the peer reviewers. So just like in cybersecurity, so just like in cybersecurity, what you do is you have a platform. You say, okay, these flaws, and let's say you're a bounty provider. So you might be an academic journal, you might be a research institution, you might even be a funding body in the sense like, a government funding institution. Say, hey, listen, for this research, we care about these flaws, and we're willing to put a monetary value on it. And again, we don't care whether you have you graduated from even secondary school. If you can find a bounty and you submit it and it's approved, you get the money. So the way it can be it can be very flexible in the sense that you might just put a pool of money and put a pool of, like, say you have 50 flaws that you are most cared about, and you just put the bounty on that. And then as the flaws are submitted and accepted, then that pool of money goes out. Now, I will say that there's no reason, just because there's no bounty on a flaw doesn't mean that anyone is prevented from submitting it. So you could submit a flaw, there may be no bounty on it, but if your interest is improving the scholarly record, why not? I mean, again, people are investigating papers today with no, they get some prestige in a very small click on, I guess, Blue Sky now, because they moved from Twitter, but outside of that, they don't get paid to. If you find a flaw in a major paper, there's almost no pay in it right now. So, and that's what I want to balance. So academia, the way it's set up, is that through the PhD process, like, they enable what I call makers, and makers are things who want to do the very hard work of doing research and publishing a paper, just like makers are in software want to build useful apps for people. But then you have breakers who get energy by pointing out flaws in other people's work. And you may not like these people, but they perform a very valuable service, because at the end of the day, truth is best discovered through adversarial processes like the Socratic method, So breakers are like hackers. And I won't even distinguish between white hat or black hat, malicious or, ethical hackers. Fact of the matter is, if there's a flaw in your piece of software and it's exposed to the public, well, it can be exploited. And in academia, I think that there's no pathway for breakers, people who really like looking at papers and finding flaws in them. There's no way for them to make a career out of this. And that's a fault of academia in general. There should be people in academia who only do this, and there should be a pathway to tenure for this. I will say that, in most other businesses, you always want to balance your metrics. So you may have one metric for production and another metric for production. In academia, there's only a metric for production. There's no, what they say is, they assume that getting published is actually a sign of quality, but it's just not true. So, referee is trying to add that quality measure that's missing from academia, and that's really needed.
And now that you also start to share with us a little bit more about these specific maybe roles that the people can take in the system, maybe you could tell us a little like example, like a kind of user story, that you could describe a little bit like all the path that maybe a paper can take and how they interact with the system.
Yeah, so I'll tell you about what the minimum viable product that I'm working on now. And how I came to it and how it's going to work. So there was a series of trials that were conducted at Dutch universities in the late 1990s and early 2000s called the decrease trials. And I can't remember, it's an acronym starting for Dutch, but it basically asks the question, if you have heart surgery, should you take a drug called a beta blocker? And this series of flawed papers, the professor or the researcher was fired, admitted the flaw, but these flawed papers got sucked up into a meta study that led to European guidance on medical guidance, and it's flawed. So the British Medical Journal looked at this. They have estimated that this caused almost 160,000 excess deaths a year. Seems like a very high number, but that is the number that they reached, which is about 800,000 excess deaths in 5 years. And they also talk about how it was, even though it was pointing out that it was flawed, and it was completely made up, that it took quite a long time before the European Medical Agency to advise their guidance. Okay, that's a separate story. But in talking to many people, including some medical school professors, they also mentioned that, and the key problem with these flawed papers was that the heartbeat ranges of the patients were just implausible. They had 53 patients. The heartbeat range was only differed by 10, and that is about 10 to the negative 26 likelihood of happening. Even if you took your own heartbeat pulse rate 53 times, you won't even get close to that. It's 10 to the negative 12. But long story short, what I'm doing now is that I'm trying to predict the past. So I'm taking these decreased papers and running through the system. So the system, the application gets pointed to a directory, and this is just for the MVP. So this is really, a lot of it is AI driven, and we can talk about the role of AI, but a paper gets put into the system.
Exactly, like a normal user, take your paper, send it in the system, and there is like a start the process.
Yeah, there's a startup process. And let's just say at the very beginning, I'm only looking for one flaw. I'm only looking for heartbeat ranges.
Okay.
And the reason why Referee is perfect for today is that these AI models have become fantastic at OCR, so that's optical character recognition, because what's preventing AI and automation and peer review has for a long time has been a lot of the important data is in tables, and a lot of academic papers, they're very variable the way that they structure their paper, but a lot of important data is in tables. And at the end of the day, you need to get that table in a format that can be read by AI. And for the most part, even the best models, probably have about 5 years ago, maybe the accuracy was about 70%, but that 30% they're missing are the table data. And then it's improved. I think Meta has a NuGet package that's about 93%, but now with like Google or Gemini 2 Flash, it's very high. So they can extract data from tables. So you have to extract the table data. Then, and this is a very difficult flaw. There are other flaws that are much easier. So let's say you extract the heartbeat data. Then you have to have data on what are normal heartbeat ranges and what is the variance between those ranges. So I have tables of that. And then I also have tables for pigs, because pig hearts are very similar to humans. So a lot of coronary or heart, coronary research is done on pigs because they're very similar. So you have to have pig heartbeat ranges, and you'd be surprised trying to get to accurate or at least statistical data on pig heartbeat ranges. They don't exist. I've read some crazy papers that but they put a heartbeat monitor on a pig and they let it play, but getting solid data on what's a normal pig heartbeat ranges, but also is the pig sedated? So have they taken some anesthesia to relax? So there are a lot of different heartbeat ranges that you have to look for. You extract the data, you say you get how many people it was measured from, Then you do statistical tests, just like was done at the British Medical Journal. And then you present it right now to different AI models. So AI models are consensus mechanisms. They give the most likely next word, right? So that's the whole basis of these language models.
You predict, yes, exactly.
So you present this to many different models, and yes, models hallucinate, but they don't hallucinate at the same time. So you basically compose a jury of AI models, and you present the data and say, listen, I think that these heartbeat ranges are flawed. And they will give each their verdict, yes or no, whether they think that flaw is plausible, or whether they think that heartbeat range is plausible or not. So I've separated out the fact gathering process from the judgment process. So it's not that I send it and say, hey, look for this flaw. I say, you go and extract all the evidence there is for heartbeat ranges. Then we do a local analysis, and then I present it to the jury, and then the jury decides whether the flaw is not. And everything is captured. So as the models get better, the research or the data that was evidence that was extracted about that flaw can be represented to new models. So like you said, maybe maybe someone disagrees that the flaw did not exist. Well, I can take that evidence and I can present it to new AI models, and I can present it to humans as well. Yeah. And then we capture all the results. So we get all the verdicts and their reasoning for the verdict. And so that's all captured. And then that flaw, if it exists, gets a 1 in the flaw database. And then it gets multiplied and we get a reliability score. So for that, I think the reliability, I don't know the weight, but essentially if you've been found, if your heartbeat ranges are implausible, I'll basically say that the reliability is close to 0. And I also will say that if the data, every paper doesn't start at 100% reliability, because there's a penalty if you don't share your data and you don't share your code. Now, I don't care if the paper is the most, cited paper and the most trusted paper from the 1950s. If we don't have the data and we don't have the code, we cannot give it 100% reliability rating. So no data, I think it starts at about 80%. I don't know the number, but there's some doubt whether we can trust this, because many times when you look at these researchers, when they actually get the Excel sheets, they can see evidence where things have been copy and pasted, for example, because the fonts are different. But that's the whole system. Now, if you're a user, you put it in this paper. Let's say you're a user and you have a paper. You can submit it, and when you submit the paper, it'll automatically get the DOI, which is the unique identifier, persistent identifier for every paper in the world. It'll extract the DOI for that paper, and you say, well, I think that the research question wasn't answered, and you can submit your evidence to why you think that is the case. Again, that will be sent to a jury, maybe of humans, including humans, but AI jury to start, because it's very cheap and
faster also,
and much faster. But there is going to be human oversight. So like I said, everything is recorded and saved. So humans will look and basically do an audit and say, is the prompt to ask the jury correct? And if they find errors, when someone says, well, this flaw was found, but it doesn't actually exist, then we go in and then we do basically an audit and say, okay, how did it get it wrong? And then we can fix it. So, but yeah, you can submit your flaws that way, whether there's a bounty or not. In the beginning, it probably won't until it gets funded. But I do see this eventually being very attractive to academic journals who can't find peer reviewers. And by the way, academic journals do not like the policeman or policewoman role of trying to find academic fraud, because they think that should be done by research organizations. And they're just in the business of finding the best papers and publishing it. And they don't really, like I said, they struggle even to do the evaluation of papers today. So for them and for conferences, that can be one source of income for a referee. And then again, funding bodies, I would hope that funding bodies would reserve even 5% of the total grant to a quality review process that's thorough.
And now that you name also the academic review and thinking about this, I will say these main stakeholders in this business model also, that is the knowledge creation. Did you have in this moment the chance to approach them, or to what is the feedback that maybe you receive from them? You see that maybe could be also interest from these bodies to maybe also support the referee project, or do you see that is something that not so?
Well, so what I've been working on this for about 2 years. I've talked to many people, including academics, including people in the publishing industry, or at least related to the publishing industry. And the biggest problem is that while many of them like the idea, it's just an idea. And and I've become convinced that the best way to get traction. So I've stopped approaching people until I have my MVP done, because I think if this is, like I said, the flaw I'm looking for, heartbeat ranges, is actually more complicated once you get into the weeds of how to find it. But if I can find a flawed paper that was that led to EU guidance, and I've looked at there's 2 recent European guidance on for heart surgery, and I think there are about 450 papers on each of them, so about 900 papers to review. I'm quite confident that I'm going to find flaws, and when I do that, I will publish that, and that will get people notice that I have a working piece of software that can identify flaws, and that there's a whole system. But until I have a piece of working software, and I have to finish that first. I will not get funding until I get that software. My frustration is that in order to get funding, you need to show a team. In order to get a team, well, you need funding. So and I've tried it many different ways, and now I'm just going like in Rambo mode and just building it myself.
And now, actually, with this last information that you shared with us, is now a question also. Can you tell us what is this current status of the project, even though you already told us a little bit, and also how the people can get involved if they will be interested to involve with the project? They need to have a specific credentials, or anybody can join, or how you see it this way in the future?
Well, so the status of the project is that I'm building the MVP myself. I think I'm getting very close to having a working model which will just detect heartbeat ranges. And then, again, the first step is that I have to predict the past. And I think, until I finish the MVP, which I hope, I don't want to make promises, but I hope that I can get that done by the end of the month. But it probably won't be worth it to bring in someone this late, because they would have to master all the code, and that can many times adding someone late to a project actually extends it. So to go, like what they say, to go fast, go alone; to go far, go with others. And what I would, really appreciate is academic experts who are very opinionated about flaws in papers. Actually, you don't even need to be an academic, but you must have some expertise or willing to learn about specific flaws. I don't care about your credentials. In fact, I think, to be very honest, I think not being in an academic track, or at least a tenure track, I think is the best candidate, because even though I expect these people eventually to join the project, I don't think they'll do that in the beginning. Because if you look at academics who have called out other people's papers, and that's another problem with academia, is that there's not a culture of open criticism, because there are repercussions if you claim that one of your peers is a fraud. And especially if you do it in a public way. And what's happened to a lot of these people, they get a lot of They get a lot of venom thrown their way just in a public space like social media. But sometimes they sometimes they may not even get promoted, and they get blacklisted essentially. It's very tough to be very honest when you especially call out fraudulent, not just like, okay, your paper has some problems, but if you accuse someone of straight fraud and say that these aren't mistakes, these are actually intentional because you haven't done the work, that becomes very risky. And, in a recent example, there was a professor at Harvard Business School who was accused of fraud, and she turned around and sued the accusers for $20 million. Interestingly, she didn't, in her case, she didn't say that she didn't commit the errors that they accused her of. It was for other reasons that they sued her. But anyways, you could face lawsuits, you could face, and so a lot of people are encouraged, like, if don't be careful about criticizing others' work. So being outside of academia is a plus. That's why I think I'm the perfect founder, because I'm not in academia and the academics cannot hurt me. But eventually, I think it'll gain more acceptance. So I don't care about credentials. What I do care about is to be somewhat committed to the project. And because in the past, I've had a lot of people, a lot of really nice people who have offered to help with some aspect like marketing or fundraising, but they could only give 4 hours a month. And I'm tremendously happy with that, with all the work they do. But for some projects, like let's say marketing, that it really slows it down. Because I'm trying to do the work of recruiting others. But again, if I can get the MVP finished, and if it's working, and if I have a paper and if I found flaws, then I'll have a need for marketing people. I still have there's always room for advisors on the project. So if you think this is an important project and you think that fixing the academic record is important to society, and I always say this is a project for society, not for academia, because people always ask, well, how will you bring academia to the project? And I'm not saying it's not for them, but I think that this project is really for society, because again, so much public money is on there, but it's not just even academics, because consulting firms, doctors, they all rely on peer-reviewed research. And if it's unreliable, there's, I don't know what the calculation is, but the amount of waste and amount of loss when you've, as a consultant, and I've done this myself, I said, hey, this is peer-reviewed. But there's so much money wasted when people are trying to do things based on flawed data. So, and of course, probably the number one thing is that funding for a team, because once there's funding, then I can recruit a team. But if anyone really is committed and says, hey, I just have to be a part of this project, I don't care, I will just review the code and not touch it until the MVP is done. Always very interested in that. I mean, I really been hoping for 2 years to find a co-founder who can run with me, who's as committed to the project that I am, and drags me forward, because I do have to make compromises in the sense that this isn't my full-time job. I make money other ways, and I would love to make this my full-time career, or put all my effort in this, but I'm not being paid for this either. So I need to find a way to get paid. I do think this is a project that will outlive myself, and I think it's one of the most unrecognized problems in society today. We all assume that peer-reviewed papers are good, and once you start digging into this subject, you realize how wrong that is.
And in this way, Erik, how, if somebody is here in this moment, what is the easiest way that somebody can contact you?
So we have a website. It's called referee-project.com, where we have a lot of information. You can reach out to me personally at Erik, ERIK, at referee-project.com. I'm very happy to talk to anyone. I'm happy to jump on a call. I think and understand their interest. It's a very simple project in the sense that at the end of the day, there's just going to be a number between 1 and 100, but it's a very complex project too. It's not something like building an app for your to-do list. This is trying to overturn an entire system worldwide with thousands of research organizations and hundreds of thousands of researchers. And I'm just one person, and I know you're helping me, Sebastian. We're two people trying to overturn an entire system. And yes, we need help. And yeah, if you have any ideas on how to help and how to contribute, I'm definitely open to a conversation.
Okay, thank you, Erik, for actually this first webinar. I will say the first one for a lot of them. I'm really also happy that you also gave me the chance today to be with you here and to also make kind of a little moderation. And I also invite the people interested in this topic, people also that they are interested not only, as Erik said, to be part of this project, to develop something and no more. If you are there and you are really interested about how to be part of something bigger, something that really can make a change in this. I'm also learning here, also in the time with Erik, also learning about this process and how really somehow every single of us can contribute a little bit to improve this knowledge creation, something that at the end will be benefit with. Yes, and yes, we invite you. We also will, if we put this video in the social networks, we will also put the information in detail about how you can contact directly to Erik. And also welcome the questions. If you maybe we would like to give those a little questions or something that you would like that we talk more in the next episode, in the next webinar, welcome. Also, the idea is that this community start to grow and the community grow with people. And this one would be really nice if we can count with you in the future.
Yes, I second that. And I also just want to mention it's not about, academic. I mean, at the end of the day, people are dying because the research is flawed or at least not reliable. So this is literally life or death, and it could be yours or someone you love. So even if you're interested, even if you're not sure if you're committed, but you want to talk more, please reach out. Always happy to have that conversation. And thank you, Sebastian, for organizing this. You've been a great help. And look forward to our next one.
Perfect. Okay, Erik, thank you for your time and have a good week.